So this morning in seminar, we went through a review of the unit circle. There were very few questions. I made up a question, more of a diploma exam style question or an exam style question that we went over as well. It is important, again, for you to be in seminar. So if you're watching this on video, I'm just reminding you that it's an expectation. We do classwork during seminar. And in this case, what that means is that we're not spending any time going over any of the assigned problems from yesterday because we've already done that. So we're going to get started here on section 4.3. And this is a little bit of a weird structure how I've done this, but we're going to do part of 4.3 today. And then tomorrow, well, not tomorrow, I guess, Monday, we're going to do another part of 4.3 and part of 4.4. So it's kind of weird. There's something that's done in this section, 4.3, that's also done in 4.4. And they almost teach it in the textbook like it's a couple of different things, and it really isn't. So we're going to do that idea, whatever that is, next week. So this is on page 10 of your unit handout. We're going to be looking at finding trigonometric ratios, and this is going to be in many ways a review of something that you've done last year in Math 20, except last year in Math 20 you were taught how to write the three primary trigonometric ratios for a point on the coordinate grid. So some things are different here. What's different is we're talking about the unit circle, and the other thing that's different is we're talking about 6 trigonometric ratios. There are actually 6. So what you learned about sine of theta and cosine of theta and tangent of theta last year in terms of coordinate trigonometry, which means in terms of x, y, and r, what you learned about those 3, you're going to learn about 3 more. We're going to make sure that we understand how to use our calculator properly, and you might go, well, I do know how to use it properly, but as soon as we introduce these new 3 trigonometric ratios, you're going to discover very early on that your calculator doesn't have a button for any of them. So it has a button for sine of theta, cosine of theta, and tangent of theta, but not for these other 3. We're going to continue to explore the unit circle by finding exact values of trigonometric ratios. So, for example, at the end of today's lesson, you should be able to tell me the exact value of the tangent of negative 11 pi over 3 radians without using a calculator. And there are ways on your calculator you could cheat and find the tangent of negative 11 pi over 6, or whatever number I said. But it's going to let you down later. Okay. There's going to be problems later where you can't kind of weasel and maneuver your way towards the answer on your calculator. It won't be possible. So far our plate is getting pretty full. We're going to add a couple more items to our plate. We're going to be determining trigonometric ratios for a point that is not on the unit circle. When you take a look at the first objective here and at this fourth objective, they are really the same, except that when it's on the unit circle, we use r as 1. When it's not on the unit circle, we cannot use r as 1. We would have to use r as something else. But this first and fourth, that pair, that first bullet and the fourth bullet, are really kind of the same thing. And then lastly, if I give you one of the 5 trigonometric ratios, and whatever those other 3 are, it doesn't matter right now. I give you one of the 5 and some additional information, you ought to be able to find the other 5. Sorry, if I give you one of the 6, you should be able to find the remaining 5. So let's get started here with a review from Math 20-1. In Math 20-1 in trigonometry, you learn about the sine law and the ambiguous case of the sine law and the cosine law. But you know what? That is just totally not relevant at all to this course. There's nothing important about that. The trigonometry here is all coordinate trigonometry. Last year in Math 20, you were taught that a rotation angle will pass through or trace out a circular arc, and the distance from the center of that circle to the point on that circle is called r. And I don't know if you have r on your diagram or not. It appears as though you don't. And I'm going to have to edit my notes to include that. There should be an r here. R is defined as the distance from the center or the distance from the vertex of the rotation angle, which is the center of the circle, to the point. And we went through this whole process last year of saying I could, and for some of you, you took Math 20-1 last semester, I could drop this down and create a right angle triangle where this is x and this is y. So x squared plus y squared equals r squared. And in fact, we did that yesterday with the unit circle, didn't we? Except r was 1. So we've already learned this, but this is a review from Math 20. What is not on here right now is x squared plus y squared equals r squared, but you should know that. The review is that cosine of the rotation angle is x over r, sine is y over r, cosine is, or tangent is y over x. Are you with me on that? Do you remember that? Vaguely? Do you remember me saying, if you had me for Math 20, that in grade 10 you're given on your formula sheet sine of theta is opposite over hypotenuse, cos of theta is adjacent over hypotenuse, tangent is opposite over adjacent. But then I said to you in Math 20, you're not given that anymore, but you're given these three instead. Well, now I'm here to tell you in Math 30, you're not given this at all on your formula sheet. You need to know sine is y over r. Cosine of the rotation angle is x over r. Tangent is y over x. Okay. The new trigonometric ratios are called reciprocal trigonometric ratios. So one of them is called secant of theta. And when you talk about cosine of theta, we abbreviate that verbally by saying cos theta, right? We have this shortened way to say cosine. We say cos. When it comes to secant theta, we don't say sec theta. You say secant theta. There's generally not an accepted way to shorten it. Cosecant of theta is the reciprocal of sine. And we'll talk about what that means in terms of reciprocal. So please focus up here and don't get ahead of me on your calculator. That's not important right now. By the way, when you say sine theta, you say sine theta. You don't abbreviate it. And every now and then somebody will say sin theta, and it's not sin theta, it's sine theta. Okay? And you don't abbreviate verbally cosecant theta. You just say cosecant theta. Tangent theta, the word tangent is abbreviated as tan, and very often that's cotangent. Very often what we do is we do abbreviate verbally the word cotangent. We will say cotan theta instead of saying cotangent theta. So these three statements are on your formula sheet. Okay? Are you with me on that? You could always look them up. But you will get used to knowing what they are. And I will tell you right now, there's kind of a pattern here. Clearly, cotangent and tangent are tied together in some way because they both have the word tangent. What I was always taught is that each pair has the phrase or the syllable co someplace in it. So tangent, cotangent, there's a co in there. Cosine, secant, there's a co. Sine, cosecant. So you would never put cosecant with cosine because that's too many cos. It's just kind of a way for you to remember how to pair them together. So what does this mean? It means, and this is going to be really tricky here for some of you, that if you ever want to find the secant of an angle, you find the cosine of the angle and then take the reciprocal of whatever you get. Okay. If you ever want to find the cosecant, you find the sine and then take the reciprocal of what you get. And by the way, it's not up here in your notes, but if secant of theta equals 1 over cos theta, I'll go to a new page. If secant of theta is equal to the reciprocal of cosine of theta, then cosine of theta is equal to the reciprocal of secant of theta. It's the only mathematical relationship in the universe that is the same for both things. So cosine of theta and secant of theta are reciprocals of each other. Okay. All right. So that's what it looks like on your formula sheet. I've kind of blotted out a whole bunch of other stuff because there's a lot more stuff. If you were to look at your formula sheet, you'll see that you have that theta equals a over r under the trigonometry. This is on the right-hand side of your formula sheet. And by the way, that whole right-hand side, I think, is trig. From stem to stern, the whole thing is trig. There's tons of trig there. So what does this mean? This top line where it says cos of theta equals sine of theta equals tan of theta equals, that's math 20. You knew that from math 20. Now I'm adding another line which says secant of theta. If cosine of theta is x over r, which it is, and secant of theta is the reciprocal of cosine of theta, then cosine of theta is r over x. You flip it over. If sine of theta is y over r, and cosecant of theta is the reciprocal of sine of theta, then we reciprocate y over r and get r over y. If tangent is y over x, then cotangent must be x over y because cotangent and tangent are reciprocals. So these above, these 6 trigonometric ratios are for any rotation angle. And these trigonometric ratios, well, you need to know. You need to know these 6 trig ratios. And it doesn't matter how far the point is from the origin. It could be 1, in which case it's on the unit circle. It could be 0.2. It could be 1,000. These trig ratios are always valid. Now, I make a point in your notes, if you turn to the next page, that if the point happens to be on the unit circle, then we don't need r. Because on the unit circle, I'll remind you here, on the unit circle, r is equal to 1. So if I tell you that sine is y over r, but it's on the unit circle, then sine is y. And this takes us back to yesterday. That's one of the things we learned about the unit circle. On the unit circle, the y-coordinate is equal to the sine of the angle. On the unit circle, the x-coordinate is equal to the cosine of the angle. Well, if r is 1, all of these statements have r's in them that are replaced with 1. This was over r, and this was r over x. But if r is 1, x over r is just x, and r over x is just 1. Do you get my drift here? That what we're really saying, everybody, is that these are the overriding rules for the 6 trig ratios, but sometimes the radius is 1, so they become a little bit simpler. All right? We're going to now spend the rest of this lesson putting this together. What is the exact value of the sine of pi over 3? So what we want to do here whenever we are asked for exact values is think of the unit circle. Okay? Could we cheat and use our calculator? Yes, you could, but it's not going to be helpful later. So pi over 3, you need to recognize what pi over 3 is. It is an angle in quadrant 1 that is here. And we're going to use the unit circle to determine the exact value of the sine. So the unit circle in quadrant 1 looks like this, approximately. And we look at this and we say sine of theta on the unit circle is equal to y. Now, I do want to address why we're using the unit circle. We're using the unit circle because we know the coordinates of points on the unit circle. If you decided that you were going to do this and you were going to use a radius here of 11 or 71, then you would need to know the coordinates of the points on a circle with that radius, and we don't. So this is why we're using the unit circle. Well, this goes back to what we were reviewing at the beginning of the seminar this morning. Is that one of those root 2 over 2, root 2 over 2 positions? No, because it's not halfway in between. So it's one of those with the half and the root 3 over 2. You can see very clearly, I hope, that if this is 1, which it is because it's on the unit circle, There's no way that that is equal to a half. You can see that if this is 1, it's reasonable to say that that is a half. And how many of you, by a show of hands, have kind of graduated towards just picturing that in your head to decide which one is the half? Yeah. That's fine. I mean, one way or another, you need to be able to determine that the coordinates of this point are a half comma root 3 over 2. So what is the exact value of sine of pi over 3? Root 3 over 2. And we did these questions last year. What does this mean? Well, one thing it means is if you take the sine of pi over 3 on your calculator, you'll get a number that root 3 over 2 is the approximation of. So go ahead now and take the sine of pi over 3 in radian mode, and you should be looking at a number of 0.866 something, I believe. Am I right? Okay. This is what I mean by cheating, because I think had I asked you to do that first, many of you would have looked at that and went, oh yeah, that's root 3 over 2. But you can't do it later. So I'll be honest with you here. All of this and this is not necessary. You want to graduate to the level where you just go sine of pi over 3. Let's see, pi over 3 is up here. I'm showing an arm position here, Ian. Pi over 3 is up here. Oh, the y coordinate is root 3 over 2. So sine of pi over 3 is root 3 over 2. That's it. What about cosecant of negative 5 pi over 4? Well, again, we're going to use the unit circle. Negative 5 pi over 4, let me get a circle going here. Negative 5 pi over 4. Pi over 4 is a 45-degree angle. That's not a fantastic circle, but it will do. Pi over 4 is a 45-degree angle, so we know the numbers are going to be the root 2 over 2's, I hope. Right? So negative means in this direction, negative 1, negative 2, negative 3, negative 4, negative 5. I'm going to erase this right away because all that is important is this statement. P of negative 5 pi over 4 on the unit circle is negative root 2 over 2, root 2 over 2. That green circle is what I've done kind of on scrap paper or in my head to figure out the position where the point is. So I'm going to get rid of it. So now how do I solve this problem? Well, I look at what's up here and I'm trying to find cosecant of theta. So this is what's going on in my head now. Cosecant of theta is, and I either go from my brain or I go to my formula sheet, the reciprocal of sine of theta. And there's two ways now to finish this problem. Let me show them both to you, because you're going to have to decide which one is suited to your needs. One of the ways is to, and I prefer this personally, is to say in your head that since sine of theta on the unit circle is y, cosecant of theta is the reciprocal of y. Y is root 2 over 2. The reciprocal of that is 2 over root 2. By the way, when you reciprocate a fraction, don't write 1 over the fraction, just flip the fraction over. Okay, so that's how my brain operates. You know, I'm going to show you a second method, and I just told you don't do this, but you might want to. You might be a very linear thinker. What that means is you need a series of steps that you have to follow to solve this problem. So you go to your formula sheet, you get that formula, and then you say cosecant of theta equals 1 over sine of theta, but sine of theta is y. And I hope everybody is basically understanding we're doing the same thing, but just the thought process is a little different. And then the person, since they're a very linear thinker, says, well, I'm going to put y in. Cosecant of theta is 1 over y, which is root 2 over 2. And then they have to clean that up maybe by multiplying the top and the bottom by 2 and getting 2 on the top and root 2 on the bottom. I hope everybody sees that what I've done here is exactly the same thing as what I did kind of in my head, but it requires less effort doing it in your head. By the way, 2 over root 2 is not an acceptable answer here. Cosecant of theta is 2 over root 2. We should rationalize that because we're taught we don't like radicals in the denominator, unless you're in calculus class with me, in which case we like them in the denominator sometimes. What do I get? I get cosecant of theta. I get 2 times root 2 in the numerator, and I get root 2 times root 2 in the denominator, which is 2. The 2 and the 2 cancel, and I get cosecant of theta equals root 2. Which, you know what, everybody? Really makes sense, because this point could be written as negative 1 over root 2, 1 over root 2. And if you flip 1 over root 2 over, you get root 2. So anyway, cosecant of negative 5 pi over 4 is root 2. Let's keep going. I'm going to pick up the pace here. Tangent of an angle is going to be the y coordinate over the x coordinate. So we need to know p of negative 11 pi over 6. So I'm going to count off negative 11 pi over 6. If I look at the unit circle, pi over 6 is a 30-degree angle. There's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11 pi over 6. How many of you knew that's where it was by just kind of thinking about it? So we're getting more and more comfortable with these. The bottom line now is you look at that point and you say, well, it's the y coordinate that's a half. The x coordinate must be root 3 over 2. They're both positive because we're talking about quadrant 1. This bit of business in the middle, which I'm going to erase right now, is only used so we can establish the x and y coordinates of the location. That's it. Now we're going to take y over x. So we have to take the y coordinate of 1/2 divided by the x coordinate of root 3 over 2. I have a complex fraction. I know that some teachers will have taught you how to deal with this in a certain way. I'm going to tell you that you need to multiply the top and the bottom by 2 to cancel those little mini denominators. I think this is the cleanest, most versatile approach that we can use for lots of things. So tangent of negative 11 pi over 6 has a value of 1 over root 3, or root 3 over 3. Just like 1 over root 2 is the same as root 2 over 2, 1 over root 3 is the same as root 3 over 3. If I take 1 over root 3 and multiply the top and the bottom by root 3, then I will get that. And, you know, I may have inadvertently misspoken a little while ago saying we don't want radicals in the denominator. Sometimes they are in the denominator in a multiple choice question in Math 30. Let's look at D now. What is the cosecant of 3 pi over 2? Well, we need to know two things. What does cosecant mean? Cosecant of theta is the reciprocal of sine of theta. Sine of theta is y. So it's the reciprocal of y. This is the reciprocal of y at p of 3 pi over 2 on the unit circle. Because if it's not on the unit circle, then it's actually the reciprocal of y over r. So 3 pi over 2 on the unit circle, that's pretty easy. That's here. Right? 1 pi over 2, or 0, 1 pi over 2, 2 pi over 2, 3 pi over 2. Well, the coordinates of that point are 0, negative 1. The y coordinate there is negative 1. Again, this is just kind of scrap work. So that means we need to take the reciprocal of this. We need to write 1 over the y coordinate, but that's negative 1. 1 over negative 1 is negative 1. So the cosecant of 3 pi over 2 is negative 1. E, what is the cosine of 240 degrees? Well, you need to locate P of 240. So I would like everybody to give this some thought. You can just look at your unit circle if you like, but remember, you don't have that unit circle on exams. So you might ask yourself, why did we spend all the time making this piece of art yesterday? The answer is to learn how to make it on your own. 240 degrees is 30 degrees shy of 270 or 60 degrees below 180. It is here. This is 240 degrees, which means we're dealing with the 1/2 root 3 over 2 pair. And you need to decide which is a half. And it turns out the x coordinate is a half. The y coordinate is root 3. Because again, I'm not going to do this every time, but if this is your circle, that looks like a half of the x distance of the circle. And they're both negative because they're in quadrant 3. So this is negative 1 over 2, comma, negative root 3 over 2. Cosine is negative 1/2 because it's the x coordinate. Secant of 45 degrees, negative 45 degrees. Well, I mean, I don't want to rush things, but really, you should know almost immediately that we're talking about 1 over root 2, comma, negative 1 over root 2 here at negative 45 degrees. How many of you thought root 2 over 2 instead? The reason why I'm using 1 over root 2 is secant is the reciprocal of cosine. It's the reciprocal of x. And if I reciprocate 1 over root 2, I get root 2. I get a nice number. If I reciprocate root 2 over 2, I get 2 over root 2, which I have to rationalize. So this is 1 over the x coordinate because the x coordinate is the cosine of that angle. So it's the reciprocal of this. This is the cosine. What's the reciprocal of it? Root 2. G, tan of 510. So I think we need our calculator here to figure out where that is. I would go 510 minus 360. I want to say 150 degrees. So that is here. Looking at my arm, it is over here where the x coordinate is negative root 3 over 2. The y coordinate is 1/2. Tangent is y over x, so we need to take 1/2 over negative root 3 over 2. Multiply top and bottom by 2, and we get an answer of 1 over negative root 3, and I'm just going to toss the negative on the top. And that's okay. It's okay to say 1 over negative root 3. You could rationalize it, but I don't care. So I give you lots of questions in this first example to try to get you used to using the unit circle. Let's move on. I don't think we need to do another one. What is the approximate value of cotangent of 7 pi over 8? So this is just about your calculator. If I said what is the tangent of 7 pi over 8, you would just go tangent 7 pi over 8. But you don't have a tangent button. Remember, though, that tangent and cotangent are reciprocals. So cotangent of 7 pi over 8 is the reciprocal of tangent of 7 pi over 8. That doesn't mean I'm going to take 7 pi over 8 and flip it over. It means I need to take the tangent of it and then take the reciprocal of that. So on your calculator, how I would enter it is 1 divided by tan of 7 pi over 8. You do need to make sure that you're in radian mode. I suppose what you could do is take the tangent of 7 pi over 8 and then go 1 divided by the answer. So this question is merely about how to calculate these on your calculator. What is the secant of negative 5 pi over 11? Well, secant is the reciprocal of cosine. So I'm going to take the reciprocal of the cosine of negative 5 pi over 11. So I enter 1 divided by cosine of, brackets, negative 5 pi over 11. And I get the answer. In this case, it's 7.03 approximately. The answer to A was negative 2.41. So, a couple of points to be made here. First of all, we're using our calculator because it says determine the approximate value. Secondly, we're using our calculator because, this is the way I'm going to say this is kind of important. Even though these angles are on the unit circle somewhere, we don't have any knowledge about the x and y coordinates of them. I mean, 7 pi over 8 is on there. I don't know where it is exactly, but it's some angle. I think it's going to be 165 degrees. It doesn't matter. It's not an angle that we have the x and y coordinates of in our brain, because 7 pi over 8 is not a special angle. Sine of 35 degrees, well, that's a grade 10 question. You just go sine of 35 degrees. And I would like everybody to calculate cos of 20. Oh, you know what? I better slow down here. When you calculate sine of 35 degrees, you have to go into degree mode, right? Okay. And now I want you to calculate cosine of 20. And I'd be willing to bet money that more of you got D wrong than right. The correct answer is 0.408. Did anybody get approximately, I'm just going to estimate here, approximately 0.9? That's because you're in degree mode still. And if you look at the 20, if you look at the number 20, this is dirty. This is what we used to call dirty pool, cheating. Somebody's cheating behind your back. There's no degree symbol. So that means you have to be in radians. You have to switch over to radians and then go cos of 20. All right, the remainder of the lesson is exactly what you did last year in Math 20, pretty much. Except we've got other trigonometric ratios and we're dealing with the unit circle. So question 3 says we have a point that lies on the terminal arm of an angle. How can we show that that point is on the unit circle? Jonathan?
If we take the coordinates negative 5 over 13 and square it with the square of 12 over 13, then and if it equals
Perfect. Because yesterday we learned that on the unit circle, x squared plus y squared is equal to 1. And I'm putting brackets here to note that we're going to make sure that we square the negative. And, you know, we could do this on paper and write 25 over 169. Negative 5 squared is 25. 13 squared is 169. 12 squared is 144 over 169. And by the way, what we're doing here is we're really questioning whether we're going to get 1. We don't know that it's equal to 1 yet. And now we have a common denominator, so we can write it as 169 for the common denominator, and the numerator will be 25 plus 144. And surprise, surprise, 169 over 169. It's equal to 1. It's on the unit circle. What does that mean? It means we don't have to think about r. We do not have to think about r. So let's take a look at part B. What is cosine of theta for this point? Sine of theta, tan of theta, secant, cosecant, cotangent. This is really easy because cos is x since it's on the unit circle. Sine is y, tan is y over x. Secant is the reciprocal of cos. Cosecant is the reciprocal of y. Cotangent is the reciprocal of tan, which would make it x over y. And we know x and y. X is negative 5/13. So cos of theta is negative 5/13. I got that right, correct? Negative 5 over 13 was what x was. Okay. Sine of theta is the y coordinate, which was 12 over 13. Secant of theta is the reciprocal of cos, so it's negative 13 over 5. I want you to notice that I always put the negative on the top. I don't like putting a negative on the bottom of a fraction. Cosecant is the reciprocal of sine. Sine is 12 over 13, which means cosecant of theta is 13 over 12. We have a little bit of work here to do with tangent because we have a fraction over a fraction. Tangent of theta will be y, which is 12/13 over x, which was negative 5/13. So I can multiply the numerator and denominator by 13 and get 12 on the top, negative 5 on the bottom, so it's negative 12/5. Cotangent would be the reciprocal of that, so we just flip it over, negative 5/12. That's it. It's really a basic kind of question, but you do have to know all 6 of these definitions. Is this point, let's take a quick look before we get to number 4 about thinking about this. Is this point on the unit circle? I mean, there's no way. The unit circle has x coordinates that go from negative 1 to 1. We've got an x coordinate of negative 3. Nowhere close to being on the unit circle. So that means cosine is not x, it's x over r, right? And sine is not y, it's y over r. Tan is just y over x. We flip all of these over for the corresponding reciprocal ratios. So, what are we missing? Well, we know x. This is x. We know y. Y is 8. We're missing r. So we're going to use x squared plus y squared equals r squared. We're going to have negative 3 quantity squared plus 8 squared equals r squared. I think, but I need help with the calculation or confirmation, that when you square negative 3 and then you add the square of 8, you get 73. Because negative 3 squared is positive 9, and plus the 64. That means r is root 73. You know, man, we're done. Just put in all the x's and y's and r's wherever the formulas say to put them. Cos will be negative 3 over root 73. Secant will be the reciprocal of that, root 73 over negative 3. And I really just prefer to put the negative on the top. It doesn't mean r is negative. It means the whole ratio is negative. Sine of theta is y, which is 8, over r, which is root 73. Flip that over for cosecant, get root 73 over 8. Tangent is y, which is 8, over x, which is negative 3. And again, I'm putting the negative on the top. It doesn't matter where I put it. Flip it over and you get negative 3/8. And I'm sure somebody's wondering, should we rationalize this and this? If you want to, if the multiple choices show that things are rationalized, then you should rationalize it, but I don't care to. Take a look at another one. Angle B lies in quadrant 2 and cotangent of theta is negative 2 over 3. Do you see how crafty I was in putting that negative there? I just put it in front. Could I write it on the top? I could. Could I write it on the bottom? I could. But since it's in quadrant 2, you know that x is negative and y is positive. So it doesn't matter where you put the negative. Cotangent of an angle is x over y. So x is basically the 2 and y is basically the 3, except x is negative 2 and y is positive 3. Does that make sense? You have to look at the quadrant. I would like you to use the Pythagorean Theorem here, in other words, x squared plus y squared equals r squared, to find out what r is the square root of. Is it 13? I'm just, if it's a written response, I know sometimes I just say, oh, this is really simple, let's just figure it out without showing our work. But if it's a written response, you would show x squared plus y squared equals r squared. I'm going to pause for a second. Am I going too fast? Be honest, am I going too fast? I apologize. Let me slow it down. So what we are doing here is we're using x squared plus y squared equals r squared. Okay. How do you find cosine of an angle, Leslie? What do we divide to find the cosine of the angle? What did we do in the previous one to find cosine? X over r, perfect. So this is x over r. So if you want to find cosine of the angle, we're going to have to take x, which is negative 2, divided by r, which is root 13, and we're done there. Arden, what do you do to cosine of an angle to find secant of an angle? Yeah, you flip it over. So you can say you do 1 over it. You can say you flip it. You can say you reciprocate it. Or you could say it's r over x. So what would we get for secant of the angle? Exactly, square root of 13 over negative 2. Would you likely see it written that way on an exam? You'd probably see the negative either out in front or on top. Dua, how do we find sine of theta? It's y over r, right? So y over r. So since y is 3 and r is root 13, it's 3 over root 13. Nick, what will we write for cosecant of theta? The reciprocal of 3 over root 13, so we would just write root 13 over 3. And finally, we don't have to, for tangent, explore this in any great detail because we were told what cotangent was. We don't have to say tangent is y over x. All we have to do is say tangent is the reciprocal of cotangent, so we flip cotangent over. Any questions with that example? Okay, I apologize for going too fast, but we're okay now? Any questions at all with this example 5? Because I think we have one more, don't we? Yeah. Okay, so example 6. This would be a classic example of a multiple choice question. Okay, where it gives you this information. It says, what is the value of cosecant of theta? And it has 4 choices. But I'm not presenting it as a multiple choice question. Secant of theta is 7 over 5. Okay, let me rewrite this. Secant of theta is 7 over 5. But in my head, I know that secant of theta is the reciprocal of, Jonathan, what is secant the reciprocal of?
Secant is the reciprocal of
Cos of theta. And we could look on our formula sheet for that, right? You don't have to memorize those. So there's a lot going on here. I'm saying secant of theta is the reciprocal, I'm just going to write it as words, reciprocal of cos of theta. And I also know cos of theta is x over r. So what does that tell me? It tells me that secant of theta is r over x. And there's going to be a whole range of skills here in this room. Some of you will have graduated already to the point where you go, secant is the reciprocal of cos. Oh, okay, secant is r over x. But you need to arrive there sooner or later. You need to be able to say what secant of an angle is in terms of x, y, and r. So now what we're going to do is associate r with 7 and x with 5. So we know x equals 5, r equals 7, and we're asked to find cosecant of theta. This is our goal. So now we got to go back to either our formula sheet or our brain and the definitions of all of these things and say cosecant of the angle is the reciprocal, this is what we're trying to find, the reciprocal of sine of theta. And sine of theta is y over r. So our goal is the reciprocal of this. This is our goal. Cosecant of theta equals r over y. This is what we're trying to find. So when I take a look at my list over here, I know r, I don't know y. So what is our goal now? Our goal now is to find y. If we know what y is, we can answer the question. So we're going to use the Pythagorean Theorem. X squared plus y squared equals r squared. So I can write 5 squared. I don't really need the brackets, but I like them. Plus y squared equals 7 squared. Can everybody do a couple of quick calculations for me and determine what we're going to have for y squared? Is it 24? So you're going to go 49 minus 25, which gives you 24. So y equals root 24. And it is an expectation, everybody, that you simplify that. Going back to earlier grades, we can write root 24 as root 4, root 6. Root 4 is 2, so 2 root 6 is root 24. Any questions on getting root 24 into 2 root 6? Some of you might have been taught to do this by taking 24 and writing it using a factor tree and pulling out pairs of numbers. Okay, before we finish this question, there is a mistake on the board. It's an intentional mistake. What is wrong with what I've written? And you maybe won't see it by looking only here. You might have to look at the whole question. Marcel? Oh, is it x we're finding? No, it is y that we're finding, I think. It is. But there's something wrong here. You may call it a technicality, but it's not a technicality, do I? It's negative. So mathematically, as soon as you take a square root, you're supposed to do this. Right? So this tells us mathematically y can be 2 root 6 or in math means it could be one or the other or both, but in this case it does mean one or the other, or negative. And Dua is saying it's negative. Why is it negative? Right. So we take a look. There's a lot going on in this question. Up here it says cotangent is negative. There's a lot of ways to figure this out, but if cotangent is negative and cotangent is x over y, that means x over y is a negative number. And what does that mean? It means that either x is positive and y is negative, in which case it's in quadrant 4. No, if x is positive and y is negative, yes, it's in quadrant 4. Or it could mean that x is negative and y is positive, which means it's in quadrant 2. So the bottom line here is we can see that since secant was positive, x has to be positive, and if x has to be positive, y has to be negative. I could have very easily told you, instead of saying cotangent is negative, I could have said and theta lies in quadrant 4. So the bottom line here is that the y coordinate of that point is actually negative 2 root 6. And now we can answer the question. Cosecant of theta would be r, which is 7, over negative 2 root 6. Again, I'm going to put the negative on the top because it looks better there. So as a multiple choice question, you might have negative 7 over 2 root 6. You might have 7 over 2 root 6. You might have 2 root 6 over 7 and negative 2 root 6 over 7. So despite my going fast there in the middle of the lesson, did I redeem myself with this and you followed this okay? All right. So lots to practice here on page 201, 1 and 2, every second letter. Just get some practice. I believe that's the section where you're finding exact values of trig ratios. So you're going to the unit circle and looking at x and y. R you don't need to look at because it's 1. Number 8. This, by the way, number 2 is just calculator work. Number 8 is basically what we were just working on with the x, y, and r. The additional problems are the meat of this lesson. How do you find Well, let me ask you a quick question here, and then I'll let you get to work. A student walks in, they look at this question, they write the following. And they apply this to that point. Why are they going to only get one of those three correct? Do I? It's not on the unit circle. Negative 12 squared plus 5 squared is not going to give you 1. This is over r, this is over r. So just be careful about that. We use that cos of theta equals x so often, we forget it only is applicable if you're on the unit circle. So the 5 questions are dealing with a number of different points that may or may not be on the unit circle. So get started on that. I just want to do my attendance on the computer, and then I will be around to help you out individually.